Hi folks, welcome back to Guido's Astro Forum and thanks so much for tuning in. CWO was kind enough to send me one of their first production versions of the Seestar S50 Smart Telescope. And interestingly, CWO refers to this telescope as an integrated solution for smart astrophotography, available for both beginner and advanced astrophotographers. All of this is available for about $499, but what does it all mean? Let's find out. Let's do some solar, lunar and deep sky astrophotography in this video and see what this telescope can do. ZWO delivers the Seestar S50 in an attractive, durable black case. The package also includes a USB-C cable for charging the Seestar S50, a solar filter for safe sun observation and imaging, and a compact carbon tripod. The Seestar S50 is a triplet apochromatic refractor telescope with an aperture of 50mm and a focal length of 250mm, which brings the f-ratio to f5. Its high-quality optics should ensure nice and crisp images of the night sky. The Seestar S50 also has an integrated Sony IMX462 camera sensor with a resolution of 2 megapixels with a pixel size of 2.9 micrometers. This combination will give you a 1.3 times 0.7 degree view of the night sky at 2.39 arc seconds per pixel. As a comparison, the full moon and the sun are about half a degree in size and should fit nicely in the field of view of the Seestar S50. The telescope weighs just 3 kilograms and is just 14 by 13 by 25 centimeters tall. The battery lasts for about 6 hours and can be recharged with a regular USB-C cable that is included. It takes photos in JPEG and TIFF and videos in MP4 or AVI format. The Seestar connects over Wi-Fi with your smartphone or tablet within a range of about 5 meters. Last but not least, this smart telescope is mounted on an LDS mount. But enough talk, let's test the Seestar S50. In order to control my Seestar S50 with my smartphone, I first had to download and set up the Seestar app. That took some effort. Let me show you the whole process so you know what to expect. You can find and download the Seestar app in the Play Store, the App Store, or directly on the ZWO website. It is important to mention that at this point, ZWO is still developing the software for the Seestar S50, and the version I used for testing was version 1.7.1. When I opened the app for the first time, it gave me general information about protecting my personal information, and after that it asked for permission to use my location to provide me with accurate weather updates, information about the night sky, and allow the Seestar to accurately go to and track objects in the sky. After accepting, it showed me an accurate weather forecast and the current phase of the moon, as well as sun and moon rise and set times for my location, which was nice. After that, I needed to give permission again to allow a Wi-Fi connection between my smartphone and the Seestar S50, so the telescope can use the location information. After that, I got an additional authorization screen that asked me for Bluetooth, Wi-Fi, location and network permissions to connect and control the Seestar S50. After clicking Enter App, I saw the Wi-Fi signal of the S50 starting with S50, followed by an underscore and letters and numbers of the telescope's Wi-Fi signal. After clicking on Connect, the app advised me to press the reset button on the Seestar S50 to confirm the connection. After pressing the reset button, it was activating the Seestar for the first time. From that point onwards, the telescope stopped speaking in Chinese to me and started speaking in English. After that, it showed me a Wi-Fi name and password, which is 12345678 by default, and it asked me to change from my home Wi-Fi signal to the Wi-Fi signal of the S50. I connected my smartphone to the Wi-Fi signal and used the provided password. After that, the app asked me to download the latest firmware. It also informed me that a solid yellow glow meant that the Seestar was updated to the latest version. After the update, I clicked OK and reconnected to the S50 Wi-Fi signal. That was the whole process to set up the app. After that, all it took was to turn on the Seestar and connect to the Wi-Fi signal to connect and control the telescope. To safely watch the sun with the Seestar S50 telescope, ZWO included this solar filter. It's very simple. Just put this solar filter in front of the telescope lens of the Seestar S50 and you're ready to safely observe the sun. Also remember, never look directly into the sun with the naked eye, as you might go blind. I went all the way up to my roof of my house to ensure I had an unobstructed view of the sky with that compact tripod. I opened the app, connected the telescope over Wi-Fi and selected solar as one of the 4 telescope modes in the app. The other 3 modes include lunar, stargazing and scenery. After selecting solar, the Seestar S50 automatically began to move and search for the sun in the daytime sky. As fate would have it, a cloud moved in front of the sun just about the same time the telescope was trying to find it, so it failed to do so. As the telescope was already close, I decided to test the virtual touch-based controls that you can use when pressing on a gray circle that appears a bit below the center on your smartphone screen. Pressing this circle opens up a picture that shows up, down, left and right arrows. The further I dragged my finger towards the edge of the virtual control, the faster the telescope moved. It didn't take me long to find the sun, but centering it on my smartphone screen wasn't easy. I found that controlling both the speed and direction in one touch-based virtual control was a bit challenging. My advice for ZWO would be to separate the speed of the telescope from the direction, so people can first set the slew speed and after that point in the direction the telescope has to move. I also found out that the telescope moved when I simply swiped my finger across my smartphone screen in any direction, so that's another option. Anyhow, I ended up leaving the solar mode altogether to restart the whole process. This time there was no cloud in front of the sun and the Seestar S50 centered the sun perfectly on my smartphone screen. After it asked for confirmation that the sun was indeed centered, it automatically started tracking the sun as indicated by the crosshair icon on the right of my smartphone screen. I also discovered you can zoom in and out without moving the telescope by pinching your smartphone screen. Place 2 fingers on your touch screen and drag them apart to zoom in, and do the reverse to zoom out. I noticed that the sun was already sharp in focus, but just to be sure, I clicked on the autofocus icon on the bottom right of my smartphone screen. A green rectangle appeared and the Seestar S50 automatically refocused on the sun. That worked perfectly. Now that the sun was centered and in focus, I selected video mode on the bottom of my smartphone screen to record a 1-minute video of the sun. I first decided to press record without selecting RAW. The Seestar S50 started recording in MP4 format. I'm showing the video on the right here. As you can see, there were lots of sunspots on the sun that day. The sun is moving towards a solar maximum in 2024, so this is a perfect time to observe and photograph the sun. I was quite happy with the quality of this video. By the way, the MP4 video and JPEG photos ended up on my smartphone and not on the Seestar M50 eMMC storage card. A 1-minute video held about 700 frames, so the Seestar S50 records the sun at about 12 frames per second. The MP4 file was about 70 megabytes in size. After shooting a 1-minute video in MP4 format, I took another 1-minute video in RAW. You can select RAW by clicking on the RAW icon in the app, after which the icon turns green. RAW videos are recorded in AVI format and end up on the Seestar S50 eMMC storage card in a folder named My Works. You can download these files by simply connecting your Seestar S50 via a USB-C cable to a laptop or PC, select the My Works folder of the Seestar and copy the files. AVI videos are much higher quality videos, and I ended up with a 1.4 gigabyte file for a 1-minute video. The RAW video is recorded in grayscale, and it's clearly meant for those of you who want to do some advanced video processing to create a sharp, stacked final image of the sun or the moon. I used AutoStacker to deblayer the video and selected and stacked 90% of the highest quality frames, and I further sharpened that picture in Registacks. If you're interested in how to process high quality AVI videos, you'll find a link to a photography tutorial I made on my channel in the video description below. The photo mode can be used to take snapshot images of the sun which end up as JPEG files on your smartphone. JPEG and MP4 files are great for people who are already happy with the live view and want to immediately share it with others. The files end up on your smartphone and you can share it directly with family or friends without having to go through more time-consuming processing options. I switched off the Seestar S50 and left it on my rooftop until nightfall. In the evening sky I could clearly see the moon, and the SEESTAR app informed me that it was in fact a 71% waxing gibbous moon. I repositioned the tripod to face the moon and started the SEESTAR app. Interestingly, after repositioning the mount, the SEESTAR app indicated that the telescope was not completely level anymore. The app showed two circles and a number indicating the number of degrees it was out of alignment. I adjusted the tripod legs until the two circles sufficiently overlapped, showing a figure below 1 degree. You need to level your telescope so the Seestar S50 can accurately find and track objects in the night sky. After that was done, I chose Lunar mode in the app. The Seestar S50 automatically tried to find the moon in the evening sky. The first attempt was unsuccessful, likely due to the fact that at the moment the stars had not yet become visible in the evening sky. I saw that the telescope was very close, so I used the touch-based virtual controls again to find and center the moon on my smartphone. The Lunar mode offers exactly the same options I already discussed in solo mode. After centering the moon, I pinched my smartphone screen to make sure the moon was in focus. That appeared to be the case. However, to make sure, I used the autofocus option again and it worked perfectly. After that, I took two videos of the moon, one in MP4 and one in RAW. Here's the MP4 video of the moon. As you can tell, the moon moves around quite a bit. This happens because in the early evening, the moon was low in the sky, only about 10 degrees above the horizon, so we are looking through a lot of air and turbulence which can make it look shaky and wobbly. It's not as clear as when the moon is higher up in the night sky. However, I always enjoy taking pictures and videos of the moon in the evening sky, which has that bluish glow. I really like the quality of this MP4 video. If you're just starting astrophotography and want a good video of the moon, this is already very nice. As mentioned, MP4 and JPEG files download directly to your smartphone and you can share it right away with family or friends. If you're getting more ambitious, you can record a RAW video in higher quality AVI format. Here's that RAW video. As said before, the Seestar S50 captures about 12 frames per second, so you'll end up with about 700 frames for a 1-minute video. The AVI file is captured in RAW, so you'll need to deblayer the video first. In AutoStacker, I needed to choose BGGR to get the right colors. Here's a processed picture of that video where I stacked 75% of the frames in AutoStacker and sharpened the picture in Registax. If you're interested in learning this technique, you'll find a link to a tutorial video about moon photography in the video description below. What is also interesting is that all videos and pictures are made in portrait mode to fit on your smartphone instead of landscape mode that better fits a television or a PC screen. So it appears that the Seestar S50 telescope caters to folks who want to share their images and pictures on smartphone platforms like TikTok, Instagram and YouTube Shorts. One feature I almost forgot to mention is that you can adjust the gain level as demonstrated here. The reason why I forgot to mention it is that the default settings are very good and I wouldn't recommend to change them when imaging the moon or the sun. I waited a bit until it was completely dark to engage in deep sky astrophotography. The Seestar app offers several options to find and image objects in the night sky. First, the start screen on the app shows tonight's best targets with a selection of objects that will be above the horizon in the night sky at your particular location. That's great for beginning astrophotographers who want a quick overview of objects to choose from. When clicking on an object, you'll see more information about the object, the position where the object is located, the current altitude in the night sky, and the path the object will take throughout the night. If you want to look at the object, you can press Go Gazing and the telescope will immediately move to that target in the night sky. A second way to find objects in the night sky is by selecting the stargazing mode on the start screen. This opens up a live view of the telescope. I'll show you how that live view works in a minute or two, but right now on the bottom right, you'll find a picture of the Big Dipper. When you click on that picture, the app opens a virtual planetarium with a view of all the objects in the night sky from your location. You can turn on the compass by selecting that icon on the top right, after which you can move your smartphone around to see in real time where all the objects are in the night sky. You can pinch to zoom in. When you like to see something, you can simply press on that object and click Go To. The telescope will then move to that object in the night sky. A third option is to select a magnifying glass on the top right of the screen. This opens up an entire menu of tonight's best targets, galaxies, nebulas, and famous astronomy catalogs like IC and Messier objects. By selecting one of those tabs, you'll be getting a whole overview of objects to choose from. You can click on an object and you'll be getting more information about that object and the option to move the telescope to that object when selecting gazing. In the list of objects, below gazing, you'll also see a center option. When selecting center, the virtual planetarium opens up again, centered on the object you've selected. From there, you can simply select Go To and the telescope moves to that object in the night sky. The final option to find the virtual sky atlas in the Seestar app is to select the sky atlas icon in the bottom menu of the app. In the virtual sky atlas, I selected NGC 6992, also known as the Eastern Veil Nebula, because it is high in the sky at my latitude in the northern hemisphere and it nicely fits the field of view of the Seestar S50. After clicking on Go Gazing, the telescope automatically moved to the position in the night sky. The blue rectangle in the sky atlas represents the position of the Seestar S50 Smart Telescope. When in position, the Seestar S50 uses plate solving to perfectly center the object in the camera's field of view. The Seestar will take a short exposure picture and will match that picture automatically with the sky atlas to determine its exact position. After that, the telescope often needs to make a small correction so that the position of the telescope represented by the blue rectangle exactly overlaps the red rectangle that represents the picture you want to take. When the two rectangles exactly overlap, the Seestar S50 reports Go To Success. I rechecked the position of the telescope in the sky atlas and noticed that the default framing was not exactly the picture of the nebula I wanted to take. So I repositioned the red rectangle to exactly represent the picture I did want to take and I selected Go To again. The Seestar used its automatic plate solving technique again to move to that position. The automatic plate solving feature of the Seestar S50 takes away lots of challenges for starting astrophotographers to find objects in the night sky. The Seestar S50 automatically does that for you. After the Seestar S50 is in position, it automatically enters a previewing and enhancing mode. This whole process is automatic and takes about a minute or two. I can only guess what the Seestar S50 software does, but perhaps the camera takes some calibration frames. I'll ask CWO about it and report it in my blog once I know more. Anyhow, once the previewing and enhancing mode are done, the Seestar S50 automatically starts to take 10-second exposure pictures of the objects you want to photograph, and it will start stacking each subsequent picture onto the previous one. This technique is well known to astrophotographers as lucky imaging. As the Seestar S50 is an altitude azimuth telescope, and it is not aligned with the celestial pole, the automatic exposure time of the Seestar S50 is limited to 10 seconds to avoid star trails or elongated stars. Each stacked picture enhances the signal to noise ratio, with the signal being the nebula and the noise being all other light like artificial light pollution at your location. Think about street lights, industrial areas, city light glow, and so on. Also note that on the right, the LP filter letters are in green. This indicates that for this nebula, the Seestar S50 telescope automatically uses the light pollution filter to enhance the ionized hydrogen and doubly ionized oxygen signal, also known as HA and O3, that's coming from this nebula, while blocking light pollution in the yellow and orange parts of the light spectrum, often associated with artificial light pollution. I noticed that the Sky Atlas has predefined if the light pollution filter should be activated for each individual object. That's wise because some objects, like galaxies for instance, emit light across the whole visible light spectrum. For these broadband objects, as they are called, it is unwise to use a light pollution filter and block light emitted by these objects. For beginning astrophotographers, it's great to see that the Seestar S50 telescope automatically makes the choice whether or not to use a light pollution filter for you. For advanced astrophotographers, there's always an option to switch off the LP filter by pressing the letters on the screen. By now you probably noticed that there's a diagonal streak running across my picture. That's probably from a satellite that reflected some sunlight as it moved across my camera's field of view. You can expect streaks from satellites and planes running across your stacked picture. As the stacking technique stacks each picture onto the previous one, you'll see that this one-time streak of the satellite slowly gets dimmer when stacking more pictures, while the nebula gets brighter because that signal is present in each picture. Let me move forward my capturing attempt for about 10 minutes. Now you'll see that the streak of the communication satellite is gone and that the nebula is getting brighter in the picture. At this point, you can only pray that there won't be new satellites or planes that fly across your stacked picture. The icons on the right of the screen also show options to adjust the gain level and to autofocus. As the Seestar S50 already performed an extensive previewing and enhancing mode before capturing the object, I did not touch these options. I captured the nebula for about 1 hour and recorded the progress on my smartphone. Let me fast forward to show you how the picture progressed during that hour. It is probably wise to keep your capturing time to about 1 hour to avoid a known issue with LS mounts that is called field rotation. Also, I only had about 1 hour of clear skies before the clouds rolled in. I was amazed to see how fast the nebula became visible. On the top right of the smartphone screen, I could see a time indicator show my total exposure time. I also saw that 1 hour of capturing took about 30% of the Seestar's battery. After about an hour, I terminated the capturing process by hitting the stop record button, and the Seestar S50 app immediately saved the stacked JPEG file to my smartphone. This is that unprocessed picture. When I connected the Seestar S50 telescope to my PC using a USB-C cable, I could download a stacked 16-bit linear TIFF file for advanced processing, but there were no individual pictures. I used the linear TIFF file to do some advanced processing like dynamic background extraction, StarNet++ to separate the stars from the nebula, some stretching, color enhancement, and some multilinear noise reduction. I ended up with this picture, and considering the fact that this was only 1 hour of capturing time, I was really impressed. Advanced astrophotographers will probably demand individual photos and calibration files, but I have to admit I was pretty happy to skip the whole stacking process and use the linear TIFF file for processing. Also, the 2 megapixel resolution of the photo made the whole post-processing process a lot faster as compared to the 26 megapixel resolution of my ASI 2600 Mono Pro camera I normally use for deep sky astrophotography. If you're a beginning astrophotographer, you're probably also interested in capturing the planets. Unfortunately, I have to disappoint you in this regard. The Seestar S50 has a focal length of only 250mm, and despite the fact that it is using a small pixel size camera that can also be used for planetary imaging, the short focal length will only reveal the planets as bright stars in the night sky. Here you can see Jupiter, for instance, with its 4 Galilean moons. In astrogazing mode, the Seestar starts stacking the picture, which is not optimal. And in lunar mode, the telescope specifically tries to find and track the moon and not the planets. Here's Saturn, by the way, pretty small. All in all, the Seestar S50 performs well in terms of moon, sun and casual deep sky astrophotography, but for planetary imaging, you're going to need another telescope. If you're interested in planetary imaging, I'm in the process of posting a planetary course online for those who joined my channel as an Astro Coffee supporter for $2.99 a month. I have to say that because of this review, I'm a bit behind, but I promise to have all the videos ready by mid-October. I'm almost ready to give you my final opinion about the Seestar S50, but let me also mention that the Seestar has a daytime scenery mode that works similar to the lunar and solar mode to image objects during the day. Also, the app features a community tab where you can share your pictures and experiences with fellow Seestar S50 users. Let me give you my final opinion after having used the Seestar S50 with the Seestar app for a couple of testing days. I have to say I'm impressed. For beginning astrophotographers, the Seestar S50 is definitely worth your consideration when you want to start astrophotography in the $500 price range. You'll get a telescope with good quality optics and a compact Sony camera sensor to take nice photos of the sun, the moon and deep sky objects like I showed you in the video. The Seestar app makes it easy to control your telescope, although the installation process takes a bit of time. The light pollution filter captures beautiful nebulas and blocks artificial light pollution, and the virtual sky atlas is filled with objects to learn about and gaze at. One of the biggest frustrations for beginners is to find objects in the night sky, but not with the Seestar S50 Smart Telescope. Just select an object you want to observe on your smartphone and the telescope automatically finds and tracks that object in the sky. Also, you don't have to worry about complex photo or video processing if you don't have the time to learn all that. The default pictures and videos you'll get on your smartphone are already good enough to share with your family, friends, or with the online Seestar community in the Seestar app. Just don't buy the telescope for planetary imaging. You'll need another telescope for that. So what about advanced astrophotographers? Well, if you already have that expensive astrophotography setup, you'll probably know the trade-offs that ZWO has made. First, the ZWO used a 2-megapixel Planetary camera sensor to keep the cost down that doesn't match the super high quality dedicated cooled astrophotography cameras. Second, the Seestar S50 Smart Telescope has an Alt-S mount which limits your exposures to 10 seconds and you'll experience field rotation with multi-hour tracking. But let's be honest here. Cool deep sky astrophotography cameras start at about $1,000 and an equatorial mount with auto-guiding for long exposure astrophotography will add another $1,000 to your bill. The Seestar S50 Smart Telescope is clearly geared towards aspiring astrophotographers and automates a lot of stuff that we as more experienced astrophotographers are used to control ourselves. But let me say you this. I like my stacked sun and moon pictures I created from the 16-bit AVI files, and I was surprised to see how well a linear 1-hour stacked picture in TIFF format could be processed in PixInsight and Photoshop. And the next time I have only 1 hour of clear skies, I might just take that Seestar S50 Smart Telescope to my rooftop instead of building up that advanced astrophotography rig. Thanks for watching, subscribe for more videos like this and leave a comment in the comment section below. Clear skies and see you in the next video.